Negative.
Well, let's decide. When are focal lengths positive and when are focal lengths negative?
What's on the arrow?
Focal lengths are positive when the optical element is what? Converging or diverging? Converging are positive focal lengths. What does this lens do? What does this mirror do?
Diverge.
It takes light like this and converges it. Right? Parallel coming light will bounce down on the top, it'll bounce up on the bottom, so this converges light. Okay? That is a converging lens, which is why the distance to the, which is why the focal length is a positive number, because it's a converging lens. Everyone agree?
Yeah.
Yes. Yes. The focal length of any circular mirror is half the radius, and then the sign is decided by whether the mirror is bent so that it converges the light or it diverges the light. Okay? Sorry? In a minute we're going to find where the image is, and the image distance will be positive, meaning it's going on the outgoing side. The image distance will be negative, meaning it's not on the outgoing side. That's what we'll figure out once we calculate it. Yeah.
How do you distance object to?
Okay. I have 4 centimeters for distance image 1. That means here to there is 4.
Yeah.
And the label on the problem means that from this lens to the mirror is 8. So 4 and 8 is 12. Okay? And then I ignore the labels on the mirror, on the lens for in and out, and I look that the mirror has incoming to the left. So I say, oh, yeah, well, it's 12 centimeters to the left of the mirror, so it's a positive 12 centimeters for object distance 2.
Okay.
Yes? Object distances are positive when the object is on the incoming. Image distances are positive when the image is on the outgoing. Yes? And then you add the word not. Okay? You don't take the opposite of those sentences by changing into out. You take the opposite of those sentences by adding the word not. Yes? Objects are always compared to the incoming side. Images are always compared to the outgoing side. I don't care whether it's a mirror or a lens. Objects compares to in, image compares to out. Every time. And object is positive when the object is on the incoming side. Image distances are positive when the image is on the outgoing side. So as long as I'm just trying to find the object distance, I ask, where's the object? This is the object for the mirror. And is it on the incoming side? The answer is yes. So therefore, distance object 2 is positive. Okay, any other questions? All right. Yes? I think your question is, well, yes. Absolutely. Correct. But what it means is that what this location for a virtual image means is that the light that enters the mirror is entering the mirror with a trajectory as though it came from here. So there really is light entering the mirror. And it looks like it came from here. And that's telling how much the light is diverging when it comes into the mirror. So yes, a virtual image can absolutely be the object for the next step. And in fact, a virtual image of one lens can wind up with a real image of the next one. Okay?
Does the virtual image appear behind here?
The virtual image, well, so you go to the bathroom and you look in the mirror. What do you see? You see yourself. Where are you? Behind the mirror. So yes, virtual images can be behind the mirror. Okay? I am not looking at anyone here, because the light from you does not go straight into my eyeballs. What happens to it on the way? Yeah, it goes through my glasses. Because the light goes through my glasses, I don't look at you. I look at a virtual image of you. Okay? Now, where is that virtual image of you? Is it on the incoming side of my glass? Is it on the, okay. Let me phrase it carefully in order that you can give me a realistic answer. There is an image of you. I'm looking at the image of you created by my glasses. Is that image on the outgoing side of my lenses? No. I sure hope not. Imagine if I saw the entire class bunched up in here. That would be sort of scary. Okay. In fact, the image I am looking at is on that side. So I am viewing a virtual image of you. Nonetheless, once the light enters my eyeball, the cornea of my eye and the lens of my eye focuses that to a real image on my retina. Because if I don't get a real image on my retina, I don't see nothing. So the virtual image of you guys formed by my glasses is then bent by my eyeball into a real image because there really is light entering my eyeball after passing through the lens. Okay? Yeah.
Would they make lenses such that if we were to look at us, we would appear as a real image in between your eyes and the glasses?
Yes, sure. The problem is that I would have very great difficulty with my eyes focusing on that because that image is way inside my near field. Okay. So, here we go. One over 12 plus 1 over distance image 2 equals 1 over 5. So what is distance image 2? You're going to have to calculate it for me, yeah.
8.57.
The radius is 10, but the focal length of a mirror is half the radius. So I had to take the 10 and divide it by 2 to get the focal length, and then I had to decide positive or negative based upon whether it's bent in a way to converge or diverge. 7.5.
8.57. What? 8.57.
I think I've heard the most votes for 8.5.
Yeah.
8.5?
Yeah.
8.6.
8.57.
So
you round
Okay, I'm gonna now. This is actually not a particularly well-designed problem. Can anybody tell me why for the upcoming step?
because it's going to be on the other side.
Because it's almost dead on top of the other lens.
Exactly.
So in order to get plenty of significant digits for object distance 3, give me a few more for this.
8.571.
8.57. Positive or negative?
Positive.
Positive, which means it's on the outgoing side. Okay? Magnification in step 2 is negative object distance over, image distance over object distance. So M2 is negative what? 0.714?
Yeah.
So, what does this mean? It flips and gets even smaller. And where is it? Just barely to the left of the lens. So, it's yet again smaller. And it's in there. Okay? Now we're not done. Okay?